Can you hear me? Thanks a lot. Excuse me. Let me share the screen. Uh, Before I share the screen, I make a record for you. Okay. Let me share my screen. Dear friend, as you know, in a previous lecture, we talked about our case study, our ATM case study, and uh, uh, we stated that you should implement make an ATM mini project in our course. Have you implementation? Have you ever worked on the implementation of the ATM case study? Please, who implemented the ATM case study? Yes, yes, okay. Yes, thanks a lot. Uh, and other students. Yes, Miss Safa and Mr. Dala. Okay. Uh, for this lesson, uh, no problem for next week, but it would be better. We want to discuss some details of the implementation, other aspects of object orientation, but you have a limited time from this lecture. It is no there is no problem. Don't worry. Okay, for your attempt. Thanks for your attempts. And I have two options. It uh, we implement the ATM class ATM study. And the second option, we start the second part. As you know, in previous lecture, I talked about four pillars of object orientation, and I have sent you the link of the short video with the same title. Uh, I hope you have seen a video and I can talk about a more official on more official lectures about object orientation or object oriented design. In the second part of the of your course, for lectures, we have four lectures. The first one is about how to finding analysis classes, as you slide title. And the second one, we talked about the relationship between classes as you experienced in ATM case study, there are several different relationships between classes, between design classes, and we should investigate them in more details in the class. In the second talked about inheritance. More especially, we talked about general and special. Part of course is very, very important for me, because in the third part of the course, use this possibility in many times, in many areas, in many design pattern. It's essential to have a good background about generalization and specialization. And the last or the fourth uh, lecture in the second part is about object. There are some principles discussed in courses and papers about using oriented in practice, and there are good experiences to talk about in class. For lectures in part two. In part one of this course, we just talked object means ATM case study. As you part which we started in previous lecture, we have 4 extra lectures, and in the third part we specifically go into design usable in practice. So for now, you can select among implementing starting the first lectures. It's needed you have enough about implementation and feed to me and recognizing have attempt enough, and use no problem. You can choose among these two activities for tonight. Okay. No answer. uh, I think it's not important for you. Yes, I hope you make a good contribution in our class. Uh, you have no feedback to any of my questions. Uh, this question is not so complex and is not hard. Why you didn't answer me? It's not acceptable. Can you hear me? No problem. I decide to go to this lecture and you have no option. It's good. Let me to start this lecture. In this part of your course, I have selected 4 lectures from Dr. Raman Ramsin from Sharif University. Sharif University, probably you know, is the best university of Iran. Has the first rank in Iran, especially in computer science and computer engineering. And Professor Raman Ramsin has good experiences in software development methodologies, in object orientation, and in design patterns. It is professor in Iran, and I used 4 lectures of him for this second part. The first lecture I selected from his object-oriented design course is the lecture 7, named Finding Analysis class. As you remember in previous lectures, in especially in our ATM case study, we have experienced and find analysis classes, for example, by doing a lexical analyzing of ATM case study. For example, that for identifying classes, we should we should detect nouns and noun phrases and make a list of nouns and noun phrases from requirement document and check them to uh, determine how some of the nouns and phrases, some of the attributes or classes, and some of them aren't important in at all in our project. We have 3 extra finding analysis classes. So in this lecture, to know about the main approaches to find analysis in each project. In each software engineering project. Uh, this is workflow is analyze a use case. I talk about the use cases slide. First, let me to define analysis classes. As you see in this output, this says analysis classes and the use case analysis classes are means to use case realizations. So we should first of all define what is analysis classes. As you see in this slide, analysis class represent a crisp, a fragile, well-defined abstraction in the problem domain. For example, in ATM class, in ATM case study, some analysis class, as you know, are ATM screen, keypad, and account number, banking database, transaction withdrawal, and so on. These analysis classes defined an abstractions define our abstractions in the so analysis classes include a set of high level candidate attributes and a set of high level operation. Each analysis class, as you see in this picture and you experienced before, contains some attributes, some high level, some operations, some services. We have experienced enough in before lectures. And in UML, we use this notation to show each analysis class. This is straightforward for you. What are good analysis classes and what are bad analysis classes? What makes a good analysis class or a bad analysis class? First, we focus on good analysis class can reflect its intent by its name. A good analysis class, its name reflects its intent, its purpose. The name imply the philosophy of this of existence of that class. Okay, it's a crisp abstraction that models one specific domain. For example, an ATM class in ATM system model those abstractions that are needed, in ATM case study. Let me see this message. What the goal of using analysis class? As you know, as I talked before, in a device cycle of each software product, we have several phases. The first phase is the second phase is analysis phase. The third one is design phase. As you know, in analysis phase, attempt to notice enough about the project to determine the parts of project or the components, the abstractions that are used in okay. And this is an introductory to design phase. So in analysis phase, we make some model the project which specify the processes, the several processes of our project or of our software product, so that in design phase by helping the analysis model. we use analysis models and as an input of the design phase. Okay, because the output of the analysis phase is the input of the design phase. Okay, so we need a good analysis model so that we hope to have good design model, and then we implement the design classes. But the design classes is an extension of analysis classes, is a analysis classes with more perfect attributes and methods. Okay, so a good analysis class maps to a clearly identifiable feature of the problem domain. Clearly identifiable feature of the problem domain. You will see some examples about these concepts. It has a small, well-defined set of responsibility. Your analysis classes should not be so big, so complex responsibilities. But a good analysis class has a small or well responsibility. Each class have in our base have about three or four responsibility and no more than. A responsibility is a contract or obligation that a class has to its clients. Each responsibility especially is a service that class should have to done, that the class have to done. A responsibility is a semantically cohesive set of operations. So responsibility in this lecture is different from operations. Each responsibility may be provided by several operations, several related operations, interrelated or dependent operations. There should only about 3 to 5 responsibilities per class. I talked about this. Our class should not have more responsibility. It should have about 3 to 5 responsibilities. We have two principles in object-oriented named cohesion and coupling. Coupling relates the dependency of each class to other classes in our project, and cohesion introduce the internal dependency of each class. Internal elements of each class should be dependent on each other strongly to make a cohesion class, to make a high cohesion class. But at the same time, we should have a low coupling because we want our class be independent from others. Possible it may be to use the services of other classes to do its responsibility, but dependency should be weak. So a good analysis class has low coupling. A class should only collaborate with a small number of other classes to realize its intent. All these points, all these issues are provided, are used in designing the ATM case study. If you check again that design, you see that we have provided these needings. Okay. And what about the bad classes? The bad classes is the opposite of the good classes. So it's trivial. A bad class, a class with only one operation is a bad class, because one operation could not specify or contribute 3 to 5 responsibility. Each class should have some responsibilities, and each responsibility should be done by some operations. Okay, so the first feature of bad classes, which smells bad, is classes with only one operation. The class with only one operation is a bad class. Or another feature of bad class is a class which stands alone. A standalone class means should be associated with a small number of other classes. But if a class which has no dependency or has relationship or association to other classes, that is a bad class. That's a bad class. Probably that this class is not a part of that project. Okay. And another feature of bad classes is named omnipotent. What's the meaning of omnipotent? A class that does everything, able to do everything. Class which has more ability, which has a power to do everything of our project, that's a bad class. That's a bad class. Responsibility are considered for all responsibilities of the project, all processes in the project is assigned to one class, and it's bad. It's not an object-oriented design. So a class that does everything is an omnipotent class, which has power to do everything of the project. A class with the inheritance of the bad real deep with a deep inheritance tree are bad classes. I think these lectures, these PowerPoints are very good, because there is no need to read more material about these concepts. It's very simple to read these slides. I searched more to find good presentations for you in this course, but I think the slides of Professor Rahman Ramseen is very good and there is no need to other resources. Uh, at the end of this portion, you can refer to the reference of these slides. A class with low cohesion is a bad class. A class with a high coupling I discussed in previous slide, in before slide, about cohesion and coupling, and these two features, low cohesion and high coupling, is the opposite point of previous slide. If you remember, in this slide, for good analysis class, we talked about high cohesion and low coupling. But for bad classes, we say that they have low cohesion and high coupling. Many very small classes in a model is bad, is a bad design, is the result of a bad design. And few but large classes in model, on the other hand, also is bad. Okay, if we have very small classes, probably we should merging some of those classes into one class. And if we have few but large classes in our model, we should decompose those large classes into smaller ones. Okay. Yes, this is the. I will send you this lecture. Don't worry about the reference. Yes, this is the lecture 7 of object-oriented design course from Dr. Ramsey. Okay, let me go ahead. As you know, I remembered about four techniques to identify analysis classes. In our ATM case study, you have experienced the lexical parsing or grammatical parsing of requirement document. As you know, for classes, for identify classes in ATM case study, we listed all nouns and noun phrases to identify classes, and verbs and verbal phrases for identifying the operations of our classes. The second approach for finding analysis classes is using tools named CRC cards. Means this term is abbreviated, is an abbreviation of class responsibility and collaborators. I will discuss about this technique tonight. The third technique or the third approach to find analysis class is based on use case analysis. And the last one is using real world analysis. I will discuss all of them tonight. And you are familiar with the first technique. Please answer me. Do you have read about these techniques in your bachelor degree? Have you ever listened about these concepts in bachelor degree? Are you familiar with these concepts or not? No, in your previous degree, in your bachelor degree, have you ever passed any course about these concepts or not? Yes. So you are familiar with these concepts. If you are familiar with these concepts, we can go ahead to the next part. We have so many concepts to talk about them in this course. If you are familiar enough with these concepts, we can go ahead to the next part. Other student, what about yours? Are you familiar with these concepts? All my friends, please answer me. No. So probably you are not familiar with these concepts. I can't be prevented from talking about him. I don't got your message. Problem. Let me go ahead, and by default, I think that you are no familiar with this. You don't know about this concept, and this is first time that I discussed about them for you. Uh, First technique, as you know and as you experienced in our case studies, noun and verb or verb analysis, which is named grammatical or lexical analyzing or grammatical parsing technique. In this technique, as you know, we collect as much relevant information about the problem domain as possible. Suitable sources of information are listed here. The model, the use case model, the project glossary, and any other documents like architecture, vision document, and etc. In our case study, we just refer to requirement document, which is provided by stakeholders, by the end users of the uh, project. But there are several materials in large projects, such as a use case model and project glossary, or architecture or vision documents. Each of these has its own definition, and in this lecture, I hope you would be will be familiar with some of these terms. Especially, we will uh, for analyzing the documentation, we look for nouns or noun phrases as we have done before. The nouns and noun phrases, as you know, are candidate classes or candidate attributes. And verb or verb phrases, as you know, are candidates for responsibilities, and operations. So we should make a good list of nouns and noun phrases for classes and attributes, and we should make a list of verbs for detecting operations and responsibilities of each class. And in the third step of this uh, analysis type, we should make a tentative allocation of the attributes and responsibilities to class, as you have experienced in the ATM case study. In the ATM case study, we briefly discussed about this technique in practice. So there is no new concept in lexical analyzing or grammatical parsing technique. But I think the CRC cards technique are new for you. As I told before, the CRC is the abbreviation of class, responsibilities, and collaborators. You know enough about class and responsibilities, but what is or what are collaborators? These terms, all of these three terms are defined here in this slide. Important things in the problem domain are written on CRC card. We should make some CRC cards like this form. For each important thing, we should allocate it one of these CRC cards. The important thing title or name should be written as a candidate class, as a class name, and the responsibilities of that important thing probably would be the responsibility of the candidate class, and the collaborators are other classes that help this class to do its responsibility. Define these concepts as stated in this slide. Class has the component of this register or record the name of the class. The responsibility part is the second part of the CRC card, which contains a list of responsibilities of that class, the functions or services that it should be performs or it should perform and provided, and even the information it's responsible to keep and provide should be listed in this section of the CRC card. And collaborators contains a list of other classes with which this class collaborates in order to fulfill its responsibilities. This class to provide its responsibility may need to call some services from in our project, so we should list all those classes, all that classes that we dependent on them, or we use the services of them to do our responsibilities. So the CRC card is the second technique of finding analysis class. Okay. But in this lecture, introduced two phases for using CRC card technique. The procedure of phase one is defined in this slide by 4 steps, and we will the procedure of phase 2 in next slide. Please take a look over this slide for a moment, and I will come back to discuss about these steps. Excuse me, I turn on my mic for a moment. Excuse me, can you hear me now? I'm sorry. Okay. Um, Thanks. Let me go ahead. As like the procedure of defines an important activity in doing analysis class in analysis phase by CRC card is named brainstorm. The brainstorm is a mechanism in which all peoples in our analysis team and all stakeholders, end users, or domain experts are present all together to gather enough information to make enough information about the project. Okay, so in the first step of this phase, uh, each one explain her points of view about the project. Explain that this is a true brainstorm. All ideas as a good idea. All ideas from all persons present in this phase for brainstorm are accepted as good idea, and all of them should be recorded. Okay, ideas are recorded but not debated. In the first step, we just record all ideas from all people in the project, include analysis team, include stakeholders, end users, or domain experts about of the project, of the problem domain. In the second step, ask the team members to name the things, the important things, the special things that operate in their business domain. For example, in banking, some things such as customers, such as ATM, such as banking database are main things that make an operations over the system. As you see, customer products are important things about each project. Write each thing on a sticky note or on a CRC card. As you saw before, the CRC card has 3 parts. This is a sticky note or a CRC card. At this step, each important thing which will be discussed by members of participants should be written on a sticky note or on a CRC card. It is a candidate class or candidate attribute of a class. Okay, stick the note on a wall or a whiteboard for discussing in later phases. Okay, all notes should be seen by all present people in this phase. Ask the team to state their responsibilities that those things might have. In this phase, we just ask them to define important thing in their point of view. Okay, in this phase, we ask them to state responsibility of those things that they recorded, they are written on sticky notes, and record these responsibilities in the responsibility compartment of the CRC card. And in the last step of this phase, working with the team to identify classes that might work together, because we should write collaborators for each class. The collaborators of each class should be identified in step 4. So for doing this, working with the team to identify classes that might work together, record collaborators in the collaborator compartment of the CRC card or of the node. Okay, this is the way of using CRC card to identifying analysis classes in 2 phases. The first phase, as I told, is brainstorm phase, and the second phase, in the second phase, the participants are just object-oriented analysts and domain experts, but not other stakeholders of the project. Okay, in this phase, we do some more special work on our classes or on our analysis classes. Phase 2, decide which sticky notes should become class and which should become attribute, and probably some of them are not class and not are neither class nor attributes. Okay, so in this phase, analysis classes must be represent a crisp abstraction in the problem domain. Certain sticky notes will represent key business concepts and clearly need to become classes. They are main classes of our project. If a node logically seems to be a part of another node, this is a good indication that it represents an attribute. It's trivial. If a node doesn't seem to be particularly important or has a very little interesting behavior, see if it can be made an attribute of another class. Probably it's related to other classes. Okay. Or in doubt about classes more perfect and probably they initiated our design classes in next phase. All things you are needed about CRC card. So the second technique of identifying analysis class is using CRC card. But as I talked before in the first of this lecture, a use case based analysis is the third technique of finding analysis class, which is complementary other techniques. It complements document analyzing or grammatical parsing technique. How this technique complements the first two discussed techniques. Start from an initial list of classes by previous two techniques. We can make a list of initial classes of our project, but we are not sure about all these extra needed in our project. These classes are perfected and defined based on use cases. Each use case have some scenarios about project which is initiated in back of system of final product, and each scenario defines our uh, project in okay. So we make a list of classes more perfect based on use cases or defined scenarios in our requirement document, as you have seen in the ATM case study. Some behavioral models such as activity diagram, if you are familiar with them, or a sequence diagram in UML, are built to show use case realization. For realizing use cases, we can use some behavioral models to define our processes, to define our scenarios in our project. Classes are identified based on the object used in units of it. So for each have one has those objects. Okay, class should provide instances which implement the behavior needed for the use cases. In this technique, to complement to complete the list of analysis classes, we check these should be performed in standard system. Okay, so new classes will be added if needed when we checking some behavioral aspects of our the objects in our system, and if we feel it's needed to define more classes and change some of the existing classes if needed. When we refining, we in this phase actually refine over the existing classes by changing the definition of them if needed according to behavioral models and so on. Uh, some stereotypes in RUP, in rational unified process, which uses use case based models to identify classes. There are many types of classes in RUP methodology. The first category of classes consists of boundary classes. What are the boundary classes? Please note that a class that mediates action between the system and its environment different classes and encapsulate specific define specific services of the system. Doing main operations of the system are control classes, and some classes defined as entity classes. The third category of classes are entity classes. What the class is a user system about for an additional system and for registered in the system. So the student class in educational system is a persistent class and is a class. It's the same for teacher class, and it's the course class, and so. But the classes abilities for enrollment of electrons. Okay, classes which make possibility to interaction with other existing systems in university or its environment. For example, using fingerprint to show the presentation, to register the present students in university are boundary classes. This is all about needed about the third technique, which named use case based analysis technique, and the last technique is about real world analysis. In real world, there are physical objects, all of them classes, all of them defined some of classes which is needed, which are needed in software. For example, you have seen that some physical devices such as cash dispensers such as screen, keypad, and all of them are classes. So this class is identified by real world. It is identified material parsing technique or physical object, as I talked about in the ATM case study. Paperwork, interfaces to the outside world, and conceptual entities. All of these types are discussed here. Physical objects, things such as aircraft, people, hotels, all of them may indicate classes. Paperwork, things like invoices, orders in order processing system. Bank books may all indicate possible classes. Beware of paper book supporting the redundant business processes that the new system might be trying to replace. Non-interfaces to outside world is so on. Please read these comments about this, or conceptual entities, things that are crucial to the operation of the business but are not manifest as concrete things, such as enrollment. Enrollment is a conceptual entity which define a class or educational program or all of these concepts could be defined as classes of our system. Uh, we should analysis model if probably create a first cut analysis model, compare the result of different methods with the results of an examination of other sources of classes, resolve synonyms and homonyms, differences between the results of the different techniques, indicate areas of uncertainty, and consolidate results into the analysis model. And this is enough of this lecture. This is the end of this lecture. The reference of this lecture, I no sound. Can you hear me? I think yes. I think it's enough for tonight. I hope you'll done your implementation of ATM case study. There are several experience in the implementation, and if needed, I will talk about the implementation of case study in next lecture. We have 3 extra lectures in this part of the course. I hope we done each lecture in a session, and uh, remain session will be dedicated to the patterns. We conclude all our findings about application design. We uh, employ these informations in these design patterns. So if you have no question, let me finish this uh, session. No question. Okay. Good night. Bye for now. I'll see you next session. Okay, okay. I'll send just now. Thank you for remembering. Thank you for your for attention.